This is a Calculus 2 class, so we're going to study trigonometric substitution. Previous session, we studied integration by part, trigonometry integral substitution method. Now, I'm going to introduce more integral technique. Let's consider two integrals. First one, look at on the top. So what kind of method you can use to solve this integration? What kind of method you can use evaluate second integration? Take a moment, think about which method you should use to evaluate the first one and second one. So I'm gonna thinking about first one. We studied previous session, so we know this integration we can use substitution method. U gonna be 1 minus x squared, du gonna be negative 2x dx. That's we're gonna do this integral when you substitution method integral square root inside 1 minus x squared gonna be, here is gonna be u, dx gonna be 1 over negative 2x du. So outside is x times 1 over 2x negative dx. So this is cancel out. X cancel out. Oh no. I'm sorry guys. This is du. So x is cancel out. So we have now integral square root to u du, and negative 1.5 outside negative 1.5. So we can do this one is negative 1.5, guys. Here is u 1.5. That's gonna be 2 over 1. I'm sorry, this is not right, guys. This one is 1.5 plus 1. U 1.5 plus 1 plus c. So this one is negative 1.5. This one is 3 over 2. That's 1 over 3 over 2, 2 over 3. Here is 1.5 plus 1. That's the 3 over 2 plus c. Now this one is cancel out here. Negative 1 over 3, u 3 over 2 plus c. U gonna be what? U is right there. That's you're gonna do. This one is negative 1.5, 1 minus x squared, 3 over 2 plus c. So first one is definitely, guys, this one is definitely use what? Use sub. How about second one? Look at the second one. Integral square root 1 minus x squared dx. There's no x here. Here is x, here's no x. We cannot do the substitution method. So that's I'm gonna introduce new integral technique here, guys. Very careful. All the integration have different technique, but most of the time you're gonna use sub. When you cannot use sub, you're gonna use different method. So I'm gonna introduce 3 different trigonometric substitution. First form is I hope you already review fundamental trigono identity. First case is looks like, guys, here is looks like square root a square minus x square. That form, this one is you're gonna substitute x is a sine theta, and then you're gonna substitute dx, gonna be derivative sine theta is cosine d theta. We're gonna substitute square root a square minus x square. Look at this. A square minus x gonna be substitute a sine theta square. So this one is gonna be square root a square minus a square sine square theta. This one is square root a square 1 minus sine square theta. You understand that? This one is another way you write a square cosine square theta, because 1 minus sine square theta is a cosine square. It's square root. Is get rid of square root a square root cosine square theta. This one is a cosine theta. That's get rid of square root by using trigonometric substitute. So I'm going to give example in next slide. Let's do the first cases. So look at very carefully, guys. Look at this one. This one is you cannot use new sub. So what do you have to do? So you're going to using trigonometric substitution. So 1 minus x squared inside the square root or quadratic form, we're going to using trigonometric substitution. Case 1 is 1 minus x squared. X going to be substitute here. X gonna be substitute. Here is 1 sine theta. You're gonna substitute sine theta, substitute everything. The x gonna be derivative of sine is cosine theta, d theta. Now, you're gonna substitute 1 minus x squared, square root 1 minus sine square theta. That's the identity, trigonometry identity. That's going to be square root cosine square theta. That's going to be cosine theta. So you understand that? So now this one is to change everything after you substitute x with sine theta. Top is cosine theta. X is sine square theta. Dx gonna be cosine theta d theta. Everyone clearly understand this one, right? Then cosine is cosine square theta. Here is a sine square theta d theta. Now look at this one. This one is trigonometric integral. So here is I'm gonna write down for you. Here is cosine theta over sine theta gonna be cotangent theta, right? So this one is a substitute. Cotangent square theta d theta. Cotangent, tangent, the power is even. That's you're gonna change it, the identity. So cotangent square theta is cosecant square theta minus 1. So this one change it. Cosecant square theta minus 1 d theta. What is antiderivative cosecant? That's gonna be what? That's gonna be cosine theta, right? Cosine theta. What is antiderivative? Negative 1. That's negative theta plus c. Here is a very important part when you use trigonometric substitution. So original integrand is a function of x. Guys, look at this function of x. This is a substitute. You have function of theta. Everyone see that? So you have go back function of x. So that case, you sketch the triangle by using this one, guys, by using this one. So this one say x is sine theta. So using right triangle, sine definition is, guys, remember, sine definition is opposite over hypotenuse. This one is hypotenuse, is one, opposite is x. So what is adjacent, guys? Adjacent gonna be square root 1 minus x squared. So based on this information, you're gonna change this one. First, you have find the cotangent. Cotangent is gonna be adjacent over opposite. Theta. How can find theta, guys? Here is very important here. Theta is right there. How can find theta here? You take inverse trigonometric. Arc sine x gonna be theta. So this one is gonna be minus arc sine theta plus c. Oh, sorry. Arcsine X plus C. That's how to solve trigonometric substitution. Let's do the case 2. Case 1 is square root. Guys, case 1 is we did square root a square minus x square. Case 2 is x square plus a square form. That case, we're going to use a tangent theta, okay? So dx going to be, derivative tangent is a secant square theta d theta. Then square root x square plus a square going to be square root x is going to be a tangent theta square plus a square square root a square tangent square theta plus a square. This one is a square root a square tangent square theta plus 1. Here is tangent square theta plus 1 is a secant square theta. This one is a square root a square secant square theta. Take out the square root a secant theta. That's you're gonna find it. I'm gonna make a mistake here, guys. Okay? That's you're gonna do it, guys. This is an example for x squared plus a squared. A squared this time is 1. What are gonna be you substitute here? X gonna be tangent theta. So make sure when you substitute everything. Dx gonna be secant square theta d theta. What is gonna be x squared plus 1? That's what we're gonna do it, right, guys? X squared plus 1 gonna be x is tangent square theta plus 1. Tangent square theta plus 1 is secant square theta. Now, let's do it. This one integral. Bottom is gonna be what? Secant square plus 1, and x square plus 1 is secant square theta. So I'm gonna put here secant square theta. dx gonna be secant square theta d theta. So this one is cancelled out. So we have here integrals 1 d theta. Oh, what is antiderivative 1? That's gonna be theta plus c. I emphasize one more time. Integration is function of x. This is theta. We're gonna plug in back. So here it is right there, guys. Look at this one. Bring it down. X is tangent theta. We are looking for a theta. Should be arctangent x plus x, right? So this one is arctangent x plus c. Someone already noticed is antiderivative 1 of x squared plus 1 is arctangent x. This is another way you prove integral 1 of x squared plus 1 dx. Now is case 3. So previous slides we did, guys, look at this, a square minus x square form, square root, right? This case, x gonna be a sine theta. X squared plus a squared form, this one is x is a tangent theta. This is the last one, x squared minus a squared form, you're gonna substitute with x equal a secant theta. Derivative secant theta is a secant theta tangent theta. Let's plug in x value here. How can simplify? Square root a square secant square theta minus a square. Common factor is a square secant square theta minus 1. Previous slide we studied this one, right? Tangent square theta plus 1 is a secant square theta. This time tangent square theta gonna be, you move the 1 the other side, secant square theta minus 1. So this one is square root a square, secant square theta minus 1 is the tangent square theta. This one is a tangent theta. So we studied 3 different cases. Guys, make sure which trigonometric substitution method you're going to use. So we're going to practice more. Next slide. Now let's practice. I'm going to give example for case 3. This is x squared minus 1. This integration is a little different from previous 2 examples because this is, guys, this is definite integral. So first, you're going to substitute on the top by using x equal, what do you have to use, guys? Is secant theta, right? Secant theta, because x squared minus 1, dx gonna be secant theta tangent theta d theta. What is the square root? X squared minus 1 is square root secant square theta minus 1. Secant square theta minus 1 is square root tangent square theta. So this is a tangent. So you have to one more step about this integration because boundary is x. So we're going to find this theta here. What is the theta going to be? So if you watch my video, here is x value is 2, 1. We are looking for the theta, right? So first you have to solve this one. Secant theta gonna be 2. Guys, make sense? Secant theta gonna be 2. That's meaning is cosine theta is 1.5. Theta gonna be pi over 3. Right? So here is a pi over 3. That's the theta. Secant theta is 1. Guys, anyone remember the secant definition is this one is gonna be 1 of cosine theta, right? So this one is cosine theta gonna be 1, theta gonna be 0. Guys, make sense? So this one is 0. So now you're gonna change everything here. Integral 1 is 0, 2 gonna be pi over 3. Square root x squared minus 1 gonna be tangent theta. X gonna be secant theta times dx right here. Secant theta tangent theta d theta. So you cannot cancel out secant theta, secant theta. So you have integral pi over 2, pi over 3 and 0, tangent square theta d theta. So anyone remember this one? How gonna find this integration? Tangent square theta is even power. You have to change it. 0 and pi over 3. Secant square theta minus 1 d theta. What is antiderivative of secant? That's gonna be tangent theta minus antiderivative 1 is theta. Where to where? 0 and pi over 3. When you plug in the 3 pi over 3 first, guys, tangent pi over 3 minus pi over 3 minus tangent 0 minus 0. You already knew this is a 0, this is a 0. Tangent pi over 3 gonna be square root 3 minus pi over 3. That's how to solve this case 3, guys. Let's practice which trigonometric substitution you're going to use with the 4 integration. So we just practice, just pick the right trigonometric substitution, this example. So more detail of evaluation of integration, you can check out my blackboard. So x squared plus a squared form, this one is going to be x gonna be using a tangent theta, okay? a square minus x square gonna be, you're gonna using x equal a sine theta. X square minus a square, you're gonna using x equal a secant theta. That's the idea of trigonometric substitution. Okay, let's just start the first one. Guys, the first one is gonna be x squared plus 4 form. Which one you're gonna use? And you're gonna using first one, right? This one is x squared plus 2 squared, right? So you're gonna using x equal to tangent theta, dx gonna be 2 secant square theta d theta. That's what you're gonna use it, this one, guys, okay? How about b? B gonna be this 1 minus x squared. So this second form, 1 minus x squared, that's gonna be x gonna be 1 square is 1, right? 1 square is 1, so that's a sine theta. You're gonna substitute. Dx gonna be cosine theta d theta. This is the really important part. You guys make sure you understand which substitution you're gonna use, okay? Number C is the form is x squared minus 9. This one is x squared minus 3 squared. This case you're gonna using third one. So x gonna be 3 secant theta, dx gonna be 3 secant theta, tangent theta d theta. That's gonna using it. D is a little tricky, guys. D is a little tricky. Look at the inside. 4x squared plus 1, something squared plus something squared. That's or something squared minus something squared. So I'm going to put this one as something squared plus 1. Inside parentheses, it's going to be 2x. Something squared plus 1, this is a variable right there. You're going to using the first one. So this time it's 2x going to be tangent theta. Okay, guys? So here is going to be, you're going to move, the 2 is the other side, it's fine. So this one is going to be, x going to be 1.5 tangent theta, dx going to be 1.5 secant theta d theta. So that's the really important part, important step to take before you start integration. Let's do the little challenging question. I'm gonna do the A part. You guys practice B part. So this one is something square plus something square or something square minus something square. So first step you have to take, make complete square, guys. So here is x squared plus 2x plus 2. Make a complete square is always complete squares, you have handle only two part, first two part. So this one is x squared plus 2x plus 2. You figured out this number. Complete square is focus on this number. This number is 2. Half of 2 is 1. 1 square is right there. You add 1 square. You have subtract 1 square. Make even. Now, first this part is gonna be complete square. So this one is x plus 1 square, 2 minus 1 plus 1. So this form is after you change this into the complete square, this one is something square plus something. Which one you're gonna use? This whole thing gonna be you put together, guys. Here is variable, here is number. So you're gonna use x plus 1 is tangent theta. Guys, make sense? So this one is now changed it. Dx gonna be secant square theta d theta. One more change. X squared plus 2x plus 2 gonna be x plus 1 square plus 1. This is tangent theta. So this part gonna be tangent square theta plus 1. This one simply secant square theta. Everybody make sense this one? Now, let's go back to original integration. So integral 1x squared plus 2x plus 2 dx. This one gonna be integral. This one is transit. X squared plus 2x plus 2 gonna be secant squared theta. Dx gonna be secant squared theta, this theta. Now, cancel out. So you have d theta. Here is 1. What is antiderivative? 1 is theta plus c. You have to less job. Here is theta. You're going to change it. Where is the theta? So can you see that this one? You find the theta. So x plus 1 tangent theta. This one change. Theta going to be arctangent x plus 1. So now this integration, this substitute back to this integration. Answer, theta is arctangent x plus 1, arctangent x plus 1 plus c.